Bismillah ar-Rahman ar-Rahim. In this video, we will see how the runtime complexity of a recursive algorithm is computed by using the back substitution method. As you know, the first step is to construct or to establish the recurrence relation of the given recursive algorithm. In this video, we will see together how to compute the runtime complexity for a given recursive algorithm that its recurrence relation is Tn equal C plus Tn minus 1. Again, by using the back substitution method. Let us see together this algorithm. The name of this algorithm is compute operation 1, as you see in the front of you. So name of this algorithm is compute operation 1. And as you see, actually, this algorithm takes an input, takes argument, which is n, it is a value. Now, and there is actually if statement that compare n with 1 if n is greater than 1, and the n, remember, is the argument that passed here. If it is greater than 1, the function will call itself again. You see, call itself again. So we call this algorithm as recursive algorithm. Why? Because the method or the function call itself again. But here, as you see, by decrement, the argument passed argument by 1. So if it is n, so call the same, call itself by decreasing the value of n by 1. Once this condition or this expression is evaluated to false, this means when n equal 1, this means this algorithm will not call itself, will return the value 1. Return the value 1. So as you see in this algorithm, there is a testing statement, comparison statement, compare n with 1. Usually this, to run this statement takes a constant amount of time. This statement takes a constant amount of time. And the second task for this algorithm is to call itself again, but by decreasing input or value by 1. Then return 1. Also 1, to return 1, this will take constant amount of time. When the algorithm return 1, this takes constant amount of time. So here again, as you see here in the front of you. So this part actually takes constant amount of time. Comparison or a test. Okay, this one. So if n greater than 1, actually this one takes, okay, here takes a constant amount of time. Let us consider this as what? As C. Constant time as C. Okay. For this one, to return 1, also this also takes a constant amount of time. We call it also C. Constant. So actually this is a termination part in this recursive algorithm. So when n equal 1, this means the algorithm is terminated. Otherwise, the algorithm will call itself again and again and again until n equal 1. So assume n equal 5. Now assume n equal 5. And we need actually to apply this algorithm, to call this algorithm. So compute operation 1 with 5. What will happen? 5 greater than 1? Yes. So this will call itself again. But here will call itself when the argument equal what? Equal 4. Okay. Now this will call, make another call for what? Compute operation 1 now, but till n equal 4. So this one will call compute operation 1 when n equal 3. This will compute, okay, here compute operation 1 when equal 2. This is will call when computer operation 1 of 1. Here stop. Algorithm 1 or end of execution. End of execution. Now we need to find the runtime complexity. Now here we need to find the runtime complexity. So runtime complexity, let us take when n a runtime complexity. Okay. Now, what is time required to run this algorithm when n equal 5 is equal what? T means what? The time required to run this algorithm when an argument equal 5 equal what? Here we need to make test. So equal constant. Need constant of time plus what? Again, this will call itself the time required to run the algorithm when the argument equal 4. Okay, this is equal what? T of 4. Now call itself when n equal 4. Again, constant plus a time when equal 3. So this one, when n equal 3, make comparison. Constant plus t equal 2. Okay. Now, when n equal 2, this is equal constant plus t of 1. T of 1 equal what? This one equal constant plus in a comparison 1 equal 1. No, go here. So in a return 1. Well, 1 to return 1 takes time, so equals. Okay. So means this one equal what? If you return, this is will equal the t that time required to find, or time required when the argument equal 5. Now let us write in general. In general, this is represent the recurrence relation in the front of you here. This is represent a recurrence relation for this algorithm. This is equal what? Whatever n. If it is greater than 1, this means the time required to run this algorithm when the argument equal 1 equal constant plus what? plus the time required to run the algorithm when the argument equal n minus 1. But now when n less than or equal 1, it is required, time required is what? Is a constant time. So we will use this algorithm. Now in general, we need to apply now. We need to apply. Now here we need to apply the back substitution. Okay, the back substitution method. Substitution method to find the runtime complexity. Now, the time required to run this algorithm when the argument equal n equal constant plus time required when the argument equal n minus 1. Time required when the parameter or argument equal n minus 1 equal what? Equal c plus time required when the argument equal n minus 2. Okay. So time required when the argument equal n minus 2 equal what? Well, constant plus time required when the argument equal n minus 3. And you can go more and more. Okay. Now we need to apply substitution. So what is the time? Now the question, what is the time required when the input or the argument equal n minus k? Equal what? See here, this is 2. This is what? This is 3. This is 1. This is what? This is 2. Here 0. Here what? 1. So this is equal what? This is equal c constant time plus what? Plus the time required when the argument equal n minus k plus 1. And 3. Here 3. Here 2. Okay. Now let us see the back substitution. Now t time required to run the algorithm when the argument equal 1 equal what? Constant plus k plus what? Plus the time required when the argument equal n minus 1. This equation. Now by applying the by substitution, what is tn minus 1 equal? Tn minus 1 equal this one. Now, okay, t time required to apply the algorithm when the parameter equal c plus what? We need now to substitute n minus 1, which is equal what? Which is equal c plus time required. Okay, I'll make it in as what? Tn minus 2. Okay. Tn minus 2. Simplify. Okay. Now simplify. We have in space here. Okay. Simplify. Now Tn equal what? Equal c plus c, 2c plus what? Plus time required when the argument equal n minus 2. Compare now. This is 2. This is what? 2. Okay. I will write this one in blue. Equal t n minus 2. Now again, we need to substitute with n minus 2. So t time required to run the algorithm when the argument equal 1 equal 2c plus, now substitute this one. This is tn minus 2, which is equal c constant plus t n minus 3. Now simplify. Now simplify. So time required equal how many c here? 2c plus c equal what? Equal 3c plus what? Plus k plus t. Time required n minus 3. C here 3 here what? 3. Now when this algorithm will stop, when this equal 1, when this equal 1. So we go more substitution, more substitution. Now, okay, now equal what this one. Now at the step k, we need at the step k, at the step k equal what? Here. So here at, you can go more here. Let's see. Remember this relation. Okay. Remember now this relation. So at step k, so t of n equal what? Equal. Hina 3, 2, 2, 2, 2. Okay. At the step k, if you remember, this is equal what at the step k? K c plus time required when the argument equal n minus k. Okay. Now when this algorithm terminated, okay, the algorithm okay, and the algorithm will stop when n minus k equal 1. We need this to be 1. Okay. Why? To return 1, to return c. This is termination. I will show you here. As you see, this is termination. Okay. And as you see, n greater than 1 call itself. When this is evaluated to false, return 1. When 1 takes constant amount of time. So now we search when n equal 1. When n equal 1, the algorithm will stop. So when n minus k equal 1, we need to find the k. So n minus k equal 1. This means what? Keep the k in the left side equal what? 1 minus n. Multiply by negative. So k equal minus 1 plus n. Rearrange the right side. K equal what? N minus 1. Now we need to substitute this one here again. So time required to run the algorithm when the parameter or argument equal n equal what? Kc plus time required when the argument equal n minus k. So again here equal what? What is k? K equal n minus 1. So we substitute this one. N minus 1 multiplied by c plus t of what? Of 1. N minus k equal 1. This is equal 1. So time required when the argument equal n, multiply him now in n by c, or minus 1 by c. So this is equal nc minus c plus, what is the time required to return the 1? Okay, remember that time required to return 1 equals c. Also equals c plus what? Plus c. Okay, plus c. So now c cancel with c. So time required to run the algorithm when the parameter equal n equal what? Equal nc. This is constant. This is a variable. So runtime complexity depends on an n. So if n equal 100 or 1000 or 10,000 or million, this is will affect the runtime for this algorithm. So this means what? What is the time complexity for this algorithm? It is big O of what? Of n, which is means linear runtime complexity. Linear runtime complexity. Okay. So thank you for attending this video. We'll see you inshallah in other videos. Assalamu alaikum wa rahmatullahi wa barakatuh.